Good morning. In the last class, we discussed the subshell electronic configuration or subshells of an atom or an element. Okay. Now, in this class, we are trying to write the electronic configuration of an element based on subshell concept. Okay. So, we know that for an atom or element, which are the subshells? The subshells are, for the first shell, K shell, the subshell is 1s, and the second shell, the subshells are 2s and 2p, and for the third shell, the subshells are 3s, 3p and 3d, and for the fourth shell, the subshells are 4s, 4p, 4d and 4f. So these are the subshells we have for an atom or element. So based on this subshell concept, let us try to write the electronic configuration of a few elements. First element, as you know, the first element in the periodic table is hydrogen. So it is hydrogen. Hydrogen atomic number is 1, and you know that when you write a number lower to the left or lower left, this number is lower left, the number is atomic number. So atomic number of hydrogen is 1. That means the number of electrons or the number of electron in hydrogen is only 1. Hydrogen is having only 1 electron because its atomic number is 1. Atomic number 1 means it has that element or atom has 1 proton or 1 electron. So here we are considering only the number of electrons. So in hydrogen, since atomic number is 1, it has only 1 electron, and this 1 electron will be entered in the first shell or the first subshell, and that means 1s. And since it is having only 1 electron, what will be the electronic configuration of hydrogen? 1s, and it has only 1 electron, 1s1. Is it clear to you? Hydrogen is having only 1 electron, and that electron will go to the first subshell. The first subshell of an atom or element is 1s, and the maximum number of electron in s orbital is 2. That you are remembering. The maximum number of electron in s orbital is 2, and p orbital it is 6, d orbital it is 10, and f orbital it is 14. These all we have discussed in the last class. And when you come to hydrogen, it has only 1 electron. That electron will enter into the first subshell, that is 1s, and since it is having only 1 electron, you can write it as 1s1. This is the electronic configuration of hydrogen. Now if you come to the second element, which is that one, helium. Helium atomic number is 2, that means helium has 2 electrons, and what will be the electronic configuration? This 2 electron will go to the first subshell, that is 1s. Therefore the electronic configuration of helium is 1s, and since it is having 2 electrons, the electronic configuration is 1s2. Clear? Helium atomic number 2, it has only 2 electrons, so the 2 electrons will go to the first subshell, that is 1s, and the electronic configuration is 1s2. Okay, now if you come to the next element, lithium atomic number 3. Atomic number 3 means it has 3 electrons, and how it is its electronic configuration. Let us see. There are 3 electrons, and out of 3 electrons, 2 will go to the first subshell 1s. Why only 2 electron is entering into the first subshell? Because the s subshell can accommodate maximum 2 electrons. Therefore, 2 electrons. Therefore, the electronic configuration of lithium, how it would be 1s2, okay, 1s2, and the remaining 1 electron will go to the next subshell, which is that one, 2s1. Clear? So look at it here. Helium atomic number 3. 3 means the helium atom is having 3 electrons. Out of 3 electrons, 2 will go to the first subshell 1s2. Clear? 1s2. The third electron, the next electron will go to the next subshell, that is 2s and 2s1. So electronic configuration is 1s2, 2s1. Clear? And if you go to the next element, beryllium, atomic number 4. Atomic number 4, the number of electron is 4. The number of electron 4, or I can write it in the top. So if you go to the next, if you go to the next element, beryllium, atomic number 4. Atomic number 4 means number of electrons, 4 electrons, number of electrons 4, and the electronic configuration. How is the electronic configuration? There are 4 electrons, 2 electrons will go to the first subshell 1s, and the remaining 2 will go to the second subshell 2s. So you are getting the electronic configuration like this: 2s2, 1s2, 2s2. Total 2 plus 2, 4. And if you come to next element, boron, atomic number 5, the total number of electrons, 5 electrons. How could be the electronic configuration? For total number of electrons 5, and the electronic configuration will be 1s2, 2s2, 1s2, 2s2, and the fifth electron, next electron will go to the next subshell 2p1. Correct? Because in the s subshell, the maximum number of electrons 2. So 1s2, 2s2, the fifth electron will enter into the third subshell, that is 2p1. Clear? Similarly, if you go to the next element, carbon, atomic number 6. So therefore, the number of electrons 6. The electronic configuration will be 1s2, 2s2, 2p2. Clear? And it will continue like that. Okay. Now you can try to write the electronic configuration of a few elements. You complete it in the next class. You can take up to 10. Carbon, next is nitrogen, oxygen, like that. You try to complete the electronic configuration up to atomic number 10. Okay. Thank you. We continue in the next class.